Please plan yourself. Okay, if you are staying some other places, plan yourself properly.
Okay.
Compulsory lab exams as well as theory exams will be offline only. You have to come to the campus and give your exams. Okay.
Okay,
So
sir.
Please make them.
now
Yeah.
we have this CN computer network presentation or USP, sir.
No, this is a USP class. Computer network, sir will be taking on Thursday.
Okay, sir. This is USP.
This is USP. Sir is on leave today.
Oh, okay, sir.
So for that. Okay.
Okay.
Yeah. Okay. So I'll just share my screen. Hope my screen is visible now. Now we start. Okay. Screen is visible? Anybody?
Yes,
Just a
sir.
confirmation. Yeah. Okay. Thank you. In the previous class, I'll just go and give an overview till the people join. Uh, we started with client-server communication. Okay, that is inter-process communication, which means that how two processes can communicate with each other, like a parent and child. We know parent can create a child process by using a fork system call. But what if a parent wants to send a message to the child, or the vice versa? What if child wants to send a message to the parent? So for that, we require a proper channel, and that is known as inter-process communication, in which one process communicates with other. That is what the overview about this chapter is. And these are the contents of the chapter. What is IPC, what are pipes, P-open, all this we studied in the previous class. So there are n number of means which are provided by Unix, which will help us for process communication. And these are one among them which are listed. So we started with initially pipe. So pipe is nothing. It is an API, okay, which is provided by the Unix only, which will help two process to communicate with each other. Okay. So we have studied about this. Pipe is a half duplex, just like a water tap pipe. Information goes from one end and it is read from the other end. It is half duplex. If some other process wants to send, again he has to create another pipe. Okay. So that is what we studied. Pipe is nothing but an API defined by the system called pipe itself, which has two file descriptors, that is two ends of the pipe. One is for reading the data, and the other end is to the write the data. And this is the diagrammatical representation. In user process, we have two ends, FD0 and FD1. So like pipe also, when they wants to communicate with each other, they will be communicating with the help of a pipe, where from one end we read the data and from other end we write the data. So this is how exactly we talked about a parent and child. When parent creates a child process, how parent writes the data to the pipe from its writing end, which we studied in the previous class only. FD1 is for writing, FD0 is for reading. These are the standard notations. So he closes his read end and opens the write end. So data flows from this end, goes to the pipe. Now the information is in pipe. Now, if child wants to read it, it has to read from the pipe, and from which end? From the read end. So it will open FD0 and close FD1. That is what we studied with this program also here. As I said, see, please read the captions carefully, students, okay? From parent to its child. So when parent is sending, first parent forks a child process. We are in the child. So if PID is greater than 0, we are into the parent process. So when parent writes, that means it has to close its reading end and open its writing end. At the same time, child will close its writing end and open its reading end. On similar lines, what if a child writes to its parent? Just the notations are changing, students. Please don't buy it. Understand the concept. So again, child process is created here. Now we are checking for child first initially. Else if PID is equal to 0. If you are in the child process, that means child is writing. So close the child's reading end and open the writing end. At the same time, for parent, close the parent's writing end and open the reading end. These are the two variations of the program which will tell me how to write a message from parent to child using a pipe. From parent to child is this program, and from child to parent is this program. Please don't get confused. Okay. Then we studied about the P open and P close. So what happened in pipe is we had to create a child process fork, we has to close some end, we has to open some end, and all this. We have to write to the pipe and so on. So all these drawbacks are overtaken by P open and P close function. They have inbuilt mechanism which will inbuilt create a child and write the information to it. Okay, so that is again P open, which is a command string which indicates what command you want to execute, and second is the type, whether you are ready setting it to the standard input or to the standard output, and P close is to close the file pointer which was opened. That is what. If the command string is read, if the command string is write, it is connected to the standard output of the command string. So this is a command string and the parent is connected to the standard output, and if it is a write, the parent is connected to the standard input of the command string. This is what we studied in P open. This was a sample code which I showed you. Then co-process we studied. So co-process is nothing but a filter. Now what is a filter? Filter is a program that reads from its standard input and writes to its standard output. If I take my laptop, the keyboard is my standard output and the screen is my standard output. So a program which reads from its input and writes to the output, we call it as a co-process. So sorry, we call it as a filter. And when a filter becomes a co-process, when the same program generates the filter input, not only reading but also it generates the filter input and reads the filter output. That means it will read the input, generate the filter input, whatever the input was there, it is generated on the output screen, and read the file output also. So a filter becomes a co-process when the same program generates the filter input and reads the filter output. That is what we studied in the co-process concept. The simple notation here. If it is usually it is asked in the exam for 5 marks. So what is co-process, and with this diagram is more than sufficient for you to get the marks. Then we studied about the FIFOs. As I said, FIFOs are used to communicate between two unrelated processes. So till now what we studied, pipe, P open, P close are used for related processes. They are unrelated, client and server communication. They are not only used to send the output to other process, but also it can be passed to T, that is output of one command can be given as an input to another. Let me show you how it is used for client server communication. So whenever the clients are available, I told you, they write to the well-known FIFO. So from this well-known FIFO, the server reads and server replies to the client from its client-specific FIFO. So if example, there are 10 clients, there will be 10 client-specific FIFO, whereas there will be only one well-known FIFO. Please keep this in mind, okay? Then these are the limitations of the FIFO, which says that whenever you are transferring the data, there must be at least one reader process and one writer process running. That means both should be running at the same time. Either one should be reading and one should be writing. Both can't be idle. And the other problem is the data is exchanged between the process must always be in the form of stream of bytes. So the message, whatever is passed for process communication, is in terms of streams of bytes. Then we said about XIPC. Now these are the again different APIs which are again used for message communication only, but the drawback of this, are overtaken by this APIs, message queues, semaphore and shared memory. We studied what is a message queue, where more than one process writes, which can be read by more than one reading process. Just like a broadcasting message, we write only one message in the WhatsApp group and it is read by all other processes, people, right? Then is semaphore, which is synchronization, right? We said, now simple example of semaphore is in the WhatsApp also. If I type something, please submit the journal. To whom am I referring there? So again, you have @ notation, you can just explicitly type the name there. So which means that it is exclusively for that process or that person, right? It's a semaphore which says that synchronization purpose. Please relate it, okay? See in WhatsApp group, if I say submit journal, to whom am I referring here? Because there are almost 70+ people in my WhatsApp group, and whom am I referring? Don't know. But if I write submit journal @ and if I type the name there, so obviously it will be shown in your list, whatever name you have saved, the person name, it is exclusively for that person. That is a semaphore. And shared memory is something like where a single block of memory is shared by 2 or more processes. So what happens if one process makes the changes to the memory, it is also visible for the other processes who are accessing it. Then we said about what is a message queues. So how message queues are created. So first and the foremost thing is you should create a message queue, then push the data to the message queue, then read the data from the message queue and control the message queue. These are the 4 identifiers used in message queues. In the exams also, if at all they asked, you have to explain what is message queues and list the various APIs or system calls associated with the message queue along with its syntax. That is what we studied. And this is the structure of the message queue, where for any message queue, what all members it has is nothing but this structure members. By default, it is once you create a message queue, it gets all the default values. You can also change it by the control API. So the first one was message get. It is used to open or create a message queue, which we studied. So once you create a message queue, then your next task is to send your message to the message queue. So how will you send a message to the message queue? By the system call MSG send, where the first attribute is the message queue which was created from MSG get. Second is the pointer with which you are passing. Next is the size, and next one is the flag, which tells me whether I am waiting or I am not waiting. Then the next field is message receive, we studied. So once you send the message to the message queue, the next task is to receive the message from the queue, and that can be got with the help of student. Just a minute. Vinit सांगा की. Vinit. Good morning. Thank you. Yeah, sorry students. Okay, going back here. Then we said about message receive. Just sharing mode. Yes, I'm sharing mode. Then is the message receive, which means that once you send the message to the message queue, next is to read the message. How can we read it? By the MSG RCV system call, which means that the first argument is again the same, is the one from which message queue you are reading, because there are n number of message queues, which is the identifier of the message queue which was created by MSG get. Then the pointer size, then the number of bytes, again the flag value. So again here the type has 3 types. If the type is 0, the first message of the queue is returned. If type is greater than 0, whose message type is equal to that is returned, and is less than 0, whose message type is lowest value than the actual value is returned for us. Then MSG control. Now this is the one which says that once you read from a message queue, you have an option to control the message queue, like change the members of the message queue, and that is done by the system called MSG CTL, which is nothing but message control. So with your MSQ ID, that is nothing but the queue ID which is specified from the MSG get. For that, depending upon the command value, it does the following operations. So if the command value is stat, it fetches the data structure of this queue. So whatever is the message queue ID you have given here, for that it fetches all these values. All these values are fetched for that. If it is IPC underscore stat, and if it is IPC underscore set, it will set the new values for that message queue. You can always change the access time, modify time, the size, the number of queues, everything. So if the command is set, it will be setting to the new value specified in that data structure. And if the command value is RMID, it will remove that specific message queue from the system. Okay. This was all about the message queue which we studied in the previous class. Next is semaphores. Now we studied this concept of semaphores in operating system. What is a semaphore? So semaphore is nothing but it is a counter used to provide access to shared resources for multiple processes. So it acts as a counter which is provided to shared resources. So what happens here? to obtain a shared resource, a process should do the following. Because for the shared resources I'm talking, so for the shared resources, what all I should do it. So first and the foremost thing is test the semaphore that controls the resource. It is very important. First test it, which is a semaphore that controls the resources of the process. And if the value of the semaphore is positive, the process can use the resource. So once you test it and if the value of the semaphore is a positive, then you can use the resource associated with that process, which means that in this case, the process decrements the semaphore value by 1, indicating that it has used 1 unit of the resource, just like a tick mark or the checklist. So whichever process gets the semaphore, it decrements the value of its semaphore, saying that whatever the resource was allocated for that is created and it is used. Otherwise, if the semaphore value is 0, the process goes to sleep mode until the semaphore value is greater than 0. That means if the semaphore value which is red is 0, that means it is having no control to access the resources and it keeps on waiting till the till the semaphore values becomes a positive value. So what happens when a process is done with the shared resources that is controlled by its semaphore, the semaphore value is incremented by 1. So once it is done, the semaphore value keeps on incrementing by 1. And if any of the process are sleeping, they are waiting for semaphore, they are made awake. So now the semaphore value is turned to positive. So once the semaphore value turns to positive, then whichever the processes which were waiting for that semaphore are now made available and a person can use that. So the common form of semaphore used here are the nothing but a binary semaphores. That is, it controls a single resource and its value is initialized to 1. So either it goes in binary form 0 or 1. So this is what a semaphore is. The next we'll study about how exactly the semaphore maintains its data structures. Just like a message queue, a semaphore also maintains its data structure for each semaphore. So which are the data structures available here? So the members is, first one is the IPC permission, which all permissions are assigned. Next one is the number of semaphores in the set. How many number of semaphores are there? Last semaphore operation and last change time. So whenever each semaphore is encountered, all these are done for it internally. And how this works? This works with the help of different functions available. So what happens is when a process needs to lock multiple resources, the ability to operate on an array of semaphore is very big advantage. So what happens is when one process wants to lock other process, then it can go with the concept of semaphores. So that can be done with various APIs available in the semaphore. The first one is, there are actually three. It is semctl, semget and semop. We will study one by one in detail. The first one is semget, semaphore get. So what is a semaphore get? This function creates a new semaphore or gives the semaphore key of an existing semaphore. What is this semaphore semget? It is used to create a new semaphore. That is, whenever you are going for resource sharing, first and the foremost thing you should create a semaphore. So how a semaphore is created? It is created by the system called semget. It creates a new semaphore or gives the semaphore key of an existing semaphore, whichever was created existing. So the different attributes are for elements of which are, one is the key, then is sems and flag. So what is the key? Key is nothing but an integral value used to allow unrelated processes to access the semaphore. So key is nothing but an integer value which allows the unrelated processes, because it is all happening with the unrelated processes to access the same semaphore. And if all the semaphores are accessed indirectly by the program, they are done with the help of using those keys. So the parameter key is used only with semget. Please make a note of it. The parameter key is only used with semget function. And the next one is nsems. Nsem is number of semaphores required. So for that process, how many number of semaphores are required is nothing but the second attribute. And this is the key which is used only with semget to create a semaphore. So once a semaphore is created, it is assigned a unique key. And for that key, how many semaphores are required? and the flag is a set of flags, that is which tells me to create, execute, or append. So depending upon the semaphore created, this semget is used to create a semaphore which says first attribute is the key value for which semaphore you are creating. Next is the number of semaphores which are created for are required, and the third one is the flag value, and second one is the semctl. Now what is semctl? This function is used for direct control of the semaphore. When you want to control a semaphore, we always go with semctl function. So what does the semctl function has? Again, it has few arguments. The first one is the sem ID. Now what is a sem ID? It is a semaphore identifier obtained from semget. Again, see, just like shared memory, sorry, message queues, which we get from the MSG get, same thing. So whenever you want to control a semaphore, first a semaphore should be created. So this sem ID is nothing but the ID which is obtained from semget. And the second one is sem number. Sem number is a semaphore number, which is the semaphore number we are talking. This is 0 for the first and only semaphore. So when I'm talking about a semaphore, it is 0 for the first and only semaphore. After that, the value changes depending upon the user values. And command is nothing but the action to be taken, and the next parameter is a union sem argument, which is an optional. The fourth parameter which I have written here, see, the fourth argument is optional. So depending upon the command request, and if it is present, then only sem num is a union of various specific commands, which says that whether you have to get all the semaphores or only get a specific semaphore, whether you have to set it or extract the values. So this fourth argument is an optional, which says that if at all you want to control a semaphore, this will only come depending upon the command value specified. So again, for this, there are various command values. So the command argument is nothing but can be performed on a specific sem ID. So here are few of the commands, that is IPC_stat. That is, it fetches the sem ID's data structure, storing in the structure pointed by the ARG buff. So whatever the sem ID specified in the structure, this one, yeah, this one, it fetches that value and gives it to the user. If it is IPC_set, then it sets the permission UID, permission group ID, and permission mode. That is for that semaphore, who is the user who has created that, to which group the semaphore belongs, and the mode, that is the permissions, read, write, and execute permission. Similarly, we have get val, we have set val, get PID, get all, set all. Get all means fetches all the semaphore values in a set. Set all means set all semaphore values which are pointed by the argument. So this system call is used to control the semaphore which is created by semget. The third one is semopt. Now what is this function used for? This function is used to change the value of a semaphore. Whichever semaphore is created initially, if at all we want to change its value, we always go with semopt. Again, it has same arguments. Sem ID is nothing but it is the semaphore identifier which you get it from the semget. Semget. And next is again the structure which tells me the members, the operations. Negative means wait, positive means give, and third one is flag, that is whether it has to wait, or if it is requesting a semaphore, it doesn't have the permissions, whether it has to undo the operation. So this is nothing but a structure which has three members. And the third argument, knobs, specifies the number of operations in the array. So on that semaphore, how many operations you need to carry out. These ones you'll understand this only with the help of a program, but these programs are so lengthy, I'll tell you. I'll try my best to get those programs and show you working model here, because this is all theoretical concept, and I've seen the previous, so maximum times they ask the theory part only of this. So I'm stressing more on the theoretical part. Okay. So these are the three operations which are performed by force for exchange of information. Okay, so this is what, again, the sum of values I'm talking. It has three cases. If the value is positive, what happens? This case corresponds to the returning of the resources by the processes. So if the value of sum of is positive, it returns all the resources by the processes. What if the value is negative? If the semaphore value is less than the absolute value, then various things will happen, whether it has to wait or it has to no wait. That is, if it is returns an error, if it has to wait, and if it keeps on counting and incrementing the calling process until it is suspended. This happens only when it is negative. And if the value is 0, that means the calling process wants to wait until the semaphore values becomes 0. So it keeps on waiting till the semaphore value which is specified becomes 0 from the user end. Okay, so this was all about the semaphores. The last concept is nothing but a shared memory. See, in the exams again I said message queues, semaphores, and shared memory. All these three you have to be thorough with the APIs, which all APIs are used, and the syntax of them. Okay. The last one is nothing but the shared memory. Now, what is a shared memory? Shared memory allows two or more processes to share a given region of memory. That is what we studied in OS also. What happens there? It is used for two or more processes to share a given region of memory. And this is the fastest form of IPC. Please make a note of this, okay? Because data does not need to be copied between the client and server. Now, no data is being copied from the client to server or from server to client. Since it is a shared memory, it directly points to the memory location and accesses the data. So among all the IPCs, interprocess communication, shared memory is the fastest one. Okay. So again, this has a structure with it. So which maintains the structure at the user end and all the members, like size of the segment in the bytes in the memory. What's the size of the segment? The last sum of PID of the creator who created the shared memory block, number of attaches, that is how many processes are accessing the memory of that, last attached time, how many processes are attached to the last detached time, how many processes left, and last change time. So whatever the modification was made in that memory location. So this is the structure which is maintained at the kernel end, unlike what we studied for message queues, shared memory, and semaphores here also. So every IPC has a structure with it which is maintained at the kernel level. Okay. So again, there are various operations or APIs available, or there are some functions which are available which can be used for shared memory concept. So the first one is SHMGET. Just like what we said there. See, now by looking at this, you feel that it is going easy. But when all comes together, you get confused which one to write where. So it is now up to your understanding how well you remember all this. SH, whenever it comes with SH, it is SEMGET here now. Okay? Because here, again, the notations are almost similar here if you see. SEMOP, SEMCTL, SEMGET. So similarly here, you have also the similar kind of notations in shared memory. So please get it, how exactly you're working it. SH and GET. So what is this used for? This is used to create a shared memory segment. Now what you want to do is, from the given memory, you want to utilize one part of the memory so that n number of processes access the same memory location, right? So once you want to do that, first and the foremost thing is you should create a memory segment. And how this memory segment can be created? It can be created by the SEMGET system call. Again, it has few parameters with it. It has few parameters. If true, it writes the shared memory ID. Since I said the memories are stored in terms of block, so whichever memory block you are referring, that ID is written and it writes -1 on error. So the first one is the key. Now, what is this key? Key is used to effectively name the shared memory segment. So whichever memory segment you are using, for that the key value is used. It is used for naming purpose, that which memory segment we are referring. And the second parameter is the size, which specifies the amount of memory required in bytes. So how much amount of memory is required by you, and that memory block can be accessed by other, is given by the size. And the third one is the flag. Flag indicates if the memory block is defined, you can create it, you can append it, or you can reuse it. So for example, if there are two processes in the system and you want them to share the same location or same memory, so for that first you should create a memory block, access a memory block that can be got by shared memory get system called SHMGET. First one is the key, which indicates the block number, which block in the memory you are referring to. Second one is the size, which tells that how much block of memory. And third one is the flag. So once this is executed successfully, it writes the memory block. So semget is used to create a memory block. Next one is sem control again, like what we had in this. So sem control is used to control the shared memory and somewhat similar than the complex one for semaphores. It is bit complex than semaphore. Same like there only, but also it works on the same concept. It is used to control the memory. Again, the value depends on the command value. Depending upon the various command value, it does the operation. And SHMID is nothing but the shared memory ID. So again, the command is the same. If it is stat, it fetches a sem ID. If it is set, it sets to the new value. If it is RMID, it removes the memory block. If it is lock, it locks the memory segment and it can unlock it. So if that memory block is only used by few people, right? Shared memory, then we can go with the concept of locking. We can go for unlocking everything. Just like a group admin thing, you have an option in WhatsApp now. Only admins can post in the group. So whoever we make an admin, they are accessible to share that or have the access to the sharing of information, like passing the message. Same concepts are used here. We are talking in general terms. This is the technical terms here. Okay. So this is used to control the shared memory block. Next one is SHMAT. SHMAT. That is, when we create a shared memory, it is not accessible by any process initially. So it has to be attached to the address space of the process. So when you create a shared memory block, it is not accessible by any process because you only just create a memory block. So once a memory block is created, after that you have to assign to some process also, right? So that some process can read it. So to do that, we use SHMAT. So SHMAT is used to attach with address space of a process, because once you allocate a memory, for that again you should assign processes also, right? That is something like once you create a WhatsApp group, you require people also in the group, right? So same thing happens here also. So memory block is created, you have created. So for that, now the next task for you is to assign processes. So that can be done by the system called SHMAT. So again, the first parameter is the ID, that is which is written by the semget. The second parameter is the address, that is at which the shared memory is to be attached to the current process, that is the address which says this. And third one is again the flag, which says that whether it is read only, write only, or read write only. So with semget, you create a memory block. So once the memory block is created, it should be assigned to the processes, and that can be done by the SHMAT. This assigns the shared memory block address space to the processes, where the first ID is the sem ID, that is the shared memory block ID. Next one is the address space, and next one is the flag, which indicates whether you are going for the read only or read write or read write only. Okay. And the last one, SHMDAT. Now SHMDT, this is nothing but which helps me to detach the shared memory block from the current processes. Just like you create and put an USB drive, right? You say remove drives and all. Same thing. When the memory block is shared, now once the process completes, you have to remove the memory block. That is unmount, just like a device we do, right? Mount and unmount. Same thing when you need to unmount it also. So whenever you want to release the memory block, that memory block can be released by the system called SHMDT. This function detaches the shared memory from the current process. What it does, it takes a pointer to the address returned by shared map. So whatever the pointer address you specified, it takes that and goes to that memory location and it detaches it. So on success, it writes 0 and -1 on error. So this is how your shared memory concept works. Similar, all three are on the similar lines only. The only things what you may get confused at the end is the commands. And in probably in the next class, I'll tell you about the programming. These three programs I'll explain in the next class. So this completes your unit 5, which was very simple, which we had designed at the initial also to keep it as simple as what we can do it. So any doubts here for you now, right from the beginning? The only thing which I can say is I don't have the notes of, I'll just first stop recording. I don't have the notes of